Explorer is sending back startling information to Earth. The Explorer 1, NASA's farthest voyaged rocket, is still traveling across unseen locales of the universe almost 50 years after its launch. Researchers are bewildered by the frightening information that this popular space probe is sending back to Earth because of what appears to be a glitch. Join us as we discuss the odd data that the Explorer has been communicating back to Earth during its sensitive space investigation. Researchers have been intrigued by getting familiar with the domain's past since the enormous detonation, and that is what motivated the launch of the Explorer 1 and Explorer 2 among other space missions. The Explorer 2 was actually the first rocket to launch, leaving from the NASA Kennedy Space Center on August 21, 1977. On September 5 of that very year, Explorer 1 was launched about 14 days later. However, how could they switch places as twins? The weight of the two probes is 720 kilos, roughly equivalent to a small car. Both were launched during a window of extraordinary out-of-planet alignments that caused a slingshot effect to launch the spacecraft from one planet to another. They have, however, had to move at different rates and in different directions. On December 15, 1977, Explorer 1 had the chance to pass its identical twin along these lines, and since then, it has been our go-to asset for learning about various realities in space-related puzzles. The first rocket to do so was this one when it started its Jovian imaging mission in 1978. It was around 265 million kilometers from our planet and sent an enormous number of photos back to us. Explorer 1 completed an exceptional 100-hour stint starting in January 1979, during which it captured 3,750 images of Jupiter's rotation to produce a time-lapse film showing 10 of the planet's turns. It had gone through the Jovian moon system in February 1979, and a month later, it discovered the small ring surrounding Jupiter. Explorer 1 also made a special revelation when it found two new moons named Chiron and M. The spacecraft was prepared for its flyby of Saturn to prevent a possible collision with Titan, one of Saturn's moons. Explorer 1 also found 4 additional moons during its orbit around Saturn, including Mimas, Enceladus, Tethys, and Dione. Our researchers chose to stop the Explorer planetary mission after the Saturn mission was completed and sent both Explorer 1 and Explorer 2 beyond our planetary system at a speed of 325 million miles per year. In January 1990, the new mission, formerly known as the Explorer Interstellar Mission, began. Some of the most renowned photographs in history portraying the Sun and the majority of the planets were taken by Explorer 1 on February 14, 1990, while it was 6 billion kilometers from the Sun. These are often referred to as the Solar System Family Portrait. There were 60 total shots taken by Explorer 1, bringing the total number of photographs taken by the spacecraft to 670, although Mercury and Mars were not visible in the photographs due to various factors. Eventually, the spacecraft's cameras were turned off to conserve power and memory before its journey to interstellar space. In addition to the interstellar probes Explorer 1 and Explorer 2, NASA also operates the Pioneer 10, Pioneer 11, and New Horizons spacecraft. Before Explorer 1 passed by, Pioneer 10 was the farthest spacecraft. Explorer 1 continued its journey for a further 14 years before it finally reached the interstellar environment on August 25, 2012, with no other spacecraft in sight. However, NASA did not publicly report the achievement until 2013. Let's move to November 2018. Both space probes have formally left the solar system. When Explorer 2 crossed the heliopause and entered the interstellar medium, Explorer 1 was estimated to be 145 billion miles or 155 million kilometers from Earth. It has continued to provide us with valuable data that no other space probe missions have been able to reveal since it entered the unseen region beyond our solar system. The spacecraft has spent the majority of its 45-year journey in space in good health. However, recently scientists have discovered some strange anomalies in its performance. Explorer 1 is currently sending confusing signals back to Earth, giving the impression that it is uncertain of its location coordinates. However, there is a surprising twist to the issue. Normally, scientists have pre-programmed Explorer to go into experimental mode or sound an alert if it becomes lost in space. However, so far it has not done so. Its antenna, which transmits data back to Earth, seems to be in excellent working order. Nonetheless, the data it has recently been transmitting is ambiguous. The interstellar traveler is operating regularly, taking instructions from Earth and executing them, as well as collecting and sending scientific data. However, readouts from the spacecraft's attitude and control system do not accurately reflect what is happening inside. According to a NASA official statement, what exactly is going on remains uncertain. Each spacecraft heading towards interstellar space, including Explorer 1 and 2, has a special 12-inch gold-plated disc that is loaded with audio and video messages as a backup in case an extraterrestrial species encounters the craft. The disc includes 35 Earth sounds, 115 life photographs, 90 minutes of Western music, and greetings from former U.S. President Jimmy Carter and former UN Secretary-General Kurt Waldheim, among other items. They are recorded in 55 different languages, so if it were found by aliens, they would presumably be trying to interpret the signals. The idea that the spacecraft is now under the direction of extraterrestrials has been quickly disproved by scientists. The spacecraft's ability to function depends heavily on the attitude and articulation control system. For starters, it always keeps its antenna pointed at Earth so that scientists can accurately receive data. Additionally, it controls how the spacecraft is oriented. Engineers monitoring the situation currently feel that the attitude system is working as it should, which only adds to the mystery we currently face. Moreover, none of the safety features designed to protect the spacecraft from danger have been activated. Susan D., project manager for Explorer 1, notes that such mysteries are par for the course at this point in the Explorer mission. The spacecraft are both around 45 years old, which is much older than what was envisioned in the mission plan. Susan D. also acknowledges that the spacecraft's engineering team will face several significant challenges in resolving the issue with Explorer 1. Due to the distance between us and the spacecraft, the difficulties are considerable, largely because the spacecraft is approximately 145 billion miles away from Earth. This vast distance presents several complexities that the team must explore carefully. A rescue operation is nearly impossible given the current technological and logistical constraints. Explorer 1 is far beyond the range of any spacecraft or repair mission that we could feasibly send. The spacecraft's incredible journey has brought it into the outer reaches of our solar system and beyond into interstellar space, where it continues to travel further away from us every day. Messages sent from Earth at the speed of light take almost 21 hours to reach Explorer 1's current location. This means that any command or instruction sent by the engineering team requires a significant amount of time to be received by the spacecraft. This delay poses a major challenge for ongoing troubleshooting and debugging. Moreover, once Explorer 1 processes the command, any response or data it sends back to Earth will take an additional 21 hours to return. This means that two-way communication between Earth and the spacecraft takes an average of 2 days. Such a delay makes it particularly challenging to implement timely solutions or iterative troubleshooting processes, which are often essential when dealing with complex technical issues. The engineering team must carefully plan and execute each command, anticipating various scenarios and possible outcomes. Unlike missions closer to Earth, where engineers can quickly send and receive commands, the long communication delay requires a more strategic and patient approach. Each command must be meticulously crafted to address the known issues without causing additional problems, considering the extended time it will take to confirm whether the command had the desired effect. The significant communication delay also means that the engineering team has limited opportunities to interact with the spacecraft. Each command sent must be effective and precise, leaving little room for error. This requires extensive testing and validation of commands on Earth before they are sent to Explorer 1. In addition to these logistical challenges, the spacecraft itself is over 40 years old, having been launched in 1977. The technology on board, although advanced at the time, is now considered outdated by modern standards. The engineering team must work with equipment and systems designed and built in the 1970s, adding another layer of complexity to the troubleshooting process. The harsh environment of space also takes a toll on the spacecraft systems. Explorer 1 has been exposed to cosmic radiation, extreme temperatures, and micrometeoroids for over 45 years. These factors contribute to the wear and degradation of its components, making it even more challenging to maintain and repair. Despite these obstacles, The engineering team remains committed to resolving the recent issues. They are exploring various theories about what may be causing the anomalies and testing potential solutions through simulations on Earth. This careful, methodical approach is crucial given the stakes involved. Any incorrect command could potentially worsen the situation or lead to a loss of communication with the spacecraft. The team is also utilizing the redundancy built into Explorer 1's systems. Like many space missions, Explorer 1 was designed with backup systems to increase its resilience to failures. The engineering team may be able to switch to these backup systems or reconfigure existing components to bypass the faulty parts. NASA stated in another announcement that until the cause of the issue is better understood, the team cannot predict how long the spacecraft will be able to continue collecting and transmitting scientific data. Nevertheless, Susan D. and the engineering team are confident that the issue will be resolved. If it is something that can be fixed with the attitude control system, it would still be difficult to address the issues we currently face. The fact that the spacecraft's ability to function depends heavily on the attitude and articulation control system means that it always keeps its antenna pointed at Earth so that scientists can accurately receive data. Additionally, it controls how the spacecraft is oriented. Engineers monitoring the situation currently feel that the attitude system is working as it should, which only adds to the mystery we currently face. Moreover, none of the safety features designed to protect the spacecraft from danger have been activated. Susan D., project manager for Explorer 1, notes that such mysteries are typical at this stage in the Explorer mission. The spacecraft are both around 45 years old, which is much older than what was envisioned in the mission plan. Susan D. also acknowledges that the spacecraft's engineering team will face several significant challenges in resolving the issue with Explorer 1.